All right, 8th grade scientists, this is Miss Kerr. I'm going to go over the Evolution 2 notes with you. There is quite a lot of information, so try to stay with me. Pause the video whenever you need to. Write down your examples and things like that. But I'm going to be talking about all the pictures and things, and you do need to know all of these examples for your end of unit test. All right, so we learned about the fossil record in the geology unit. So we know that it is a record of all the fossils found by scientists on Earth. And we know that simpler organisms were found to be the oldest, so in the oldest rock. And then we have more complex organisms that live more recently. So they are in the younger rock layers. So we have on there oldest equals simple, whereas more recent equal complex. And scientists use the fossil record as evidence for evolution, that over time organisms have gotten more complex. So one kind of fossil they use as evidence for evolution is transitional fossils. So they show some intermediate stages between ancestors and what exists on Earth, maybe even today. So the example right here is the gray whale today. Its nostrils are at the top of the skull, and obviously here's the mouth. And we can see that, there is a transition from 50 million years ago, the Pachycetus, where the nostril was toward the front of the skull. And then we have a transition happening over time to the Adiocetus, which was 25 million years old. And its nostrils were in the middle of the skull. So you have front of the skull, middle of the skull, now top of the skull. So over time, it has changed to adapt to its environment. All right, we have what's called comparative anatomy. And on page 8 of your packet, you're going to take a closer look at some comparative anatomy. But you're looking at the anatomy of different organisms. So up in the right-hand corner here, we have the human arm, we have the cat leg, we have the whale, okay, and then the bat. And as you're going to look at on page 8 of your packet, you're going to look at, for instance, the humerus. We see a humerus in the human, we see a humerus in the cat, the whale, and the bat. And so through natural selection, structures have been better adapted to the organism's habitat. Obviously, a whale uses its fin very differently than we use our arm. Some ways it could be the same, but a lot of ways a whale's fin is going to be used differently by the whale than a human arm. So it's adapting to its environment. In the Evolution 1 notes, you talked about Charles Darwin and the Galapagos finches. And so he studied finches on the Galapagos Islands. And these finches adapted to their environment. Their beaks were different in order to be able to eat and access their food. So I know my picture here is a little bit hidden, but their beak sizes were different based on what they needed to eat in order to survive, right? So comparative anatomy is comparing bone structures and how they might function differently. So you have obviously hand, leg, fin, the bones of those things, and then maybe, your finch beaks that you're comparing. Why do they have different beaks? All right, next part is vestigial structures. And we have a few examples here for you. So vestigial structures really have no present-day function, but they may have had a function in their ancestors. So some examples are your coccyx, which is your tailbone right here, and this is kind of a zoomed in version, okay? The tailbone, you could do without it. Obviously, people don't take it out, but you could live without your tailbone, okay? Down here is your appendix. People do get their appendix taken out, and they survive perfectly fine. They don't die, okay? Same thing with wisdom teeth. We really no longer need our wisdom teeth. Some people have to have them taken out to make more room in their mouth these days. And we get them taken out with no harm to, you know, our ability to eat or anything like that. All right, moving on to embryology. So down here in the picture, we have 4 different embryos. Embryos are unborn animal babies. So the development of many organisms, specifically animals, look very much the same. So without kind of revealing the names here, you can kind of maybe guess what these are. So you see gill slits and the tail here. So what makes you think of gills? What kind of organism? Try and think about that. And it implies a common ancestor. So let's go ahead and reveal and take a look here. All right, so gills may have made you think of fish. Fish have gills and they have tails, okay? And so we see very similar structures in the reptile embryo. So, you know, when the organism is first created, it is an embryo. All right, moving on to the bird here. Same thing, and then behind here, behind my picture is the human. Okay, so obviously we're not saying that the human came from the bird. That's not what scientists think. It means that they have a common ancestor. As they develop, right, the bird ends up looking very different than the human. But as the embryo starts out, very much the same, right? So this is another reason or a piece of evidence for evolution.